Hello hackers and welcome back to HackProKP, the ultimate destination for mastering ethical hacking. I'm your guide Kailash Parshad and today we are diving into the heart of network communication, the OSI model. But before we unravel the layers of this crucial framework, if you haven't already, hit the subscribe button, ring the notification bell and join a growing community of ethical hackers. Trust me, you don't want to miss any of the exciting content we have coming your way. The OSI model. The OSI Open System Interconnection Model is a conceptual framework that standardizes the function of a telecommunication or computing system into 7 abstraction layers. Each layer serves a specific purpose and interacts with the layers above and below it. The model was developed by the International Organization for Standardization (ISO) to facilitate communication between different systems and devices. Simply put, the OSI model describes 7 layers that computer systems use to communicate over the network. Those 7 layers are as follows. Physical layer. Layer 1 deals with the physical connection between devices. It defines the hardware elements such as cables, connectors, and the transmission medium. It deals with the physical transmission of bits over a medium. The bits are represented by electrical voltages, light pulses, or radio waves depending on the nature of the transmission medium. Example: Ethernet and USB cables. Example of the cables could be Cat6 cables or RJ45 connector cables. Data link layer. Layer 2 responsible for creating a reliable link between two directly connected nodes. Data at this layer is organized into frames. Frames include both data and control information such as MAC addresses for device identification. Error detection and correction also happens at this layer. Example: switching, MAC, media access control addresses. Network layer. Layer 3 focuses on logical addressing and routing of data packets between different networks. It determines the best path for data to travel from the source to the destination across multiple networks. Data is encapsulated into packets at this layer. These packets include information about the source and destination network addresses, allowing routers to make decisions about forwarding the packets. Example: IP, Internet Protocol addresses, and routing. Transport layer. Layer 4 manages end-to-end communication, ensuring the data is delivered reliably and error-free. It also handles flow control. Segmentation of data occurs at this layer. For TCP, the data is divided into segments, and each segments receive a sequence number for proper reassembly at the destination. UDP, being connectionless, uses datagrams without sequence numbers. Example: TCP, Transmission Control Protocol. UDP, User Datagram Protocol. Session layer. Layer 5 establishes, maintains, and terminates sessions or connections between applications. It manages dialog control and synchronization. The session layer manages dialog control between devices, and the data unit at this layer helps establish, maintain, and terminate sessions. This layer doesn't define a specific data structure but defines the flow of data between applications. Example: session management, NetBIOS, Network Basic Input-Output System. Presentation layer. Layer 6 responsible for translating between the application layer and the lower layers. It deals with the syntax and the schematics of information exchange between systems, handling tasks such as data compression, encryption, decryption, character set conversions, and formatting. Example: JPEG, GIF, MP4, MOV, WAV, media files. Application layer. Layer 7 deals directly with the end user and provides network services to application processes. Data is presented in a format that is meaningful to the user or application. It is the layer where the actual communication occurs between software applications. Protocols at this layer are specific to particular applications, such as HTTP for web browsers or SMTP for emails. Example: HTTP, Hypertext Transfer Protocol. SMTP, Simple Mail Transfer Protocol. FTP, File transfer protocol. Forms of data at each layer. Physical layer, bits. Data link layer, frames. Network layer, packets. Transport layer, segments in the case of TCP or datagrams in the case of UDP. Session layer, message or data. Presentation layer, message or data. Application layer, message or data. Hardware versus software based layers. Now, here is a quick tip to remember. The first three layers, physical, data link, and network, are hardware based, requiring specific devices like switches and routers. On the other hand, the last three layers, session, presentation, and application, are software based, operating without the need of special hardware. And the transport layer, sitting right in the middle, is the heart of the OSI model, more software based than hardware based. It is very important to remember the OSI layers, so for that, here are some easy mnemonics or acronyms to remember OSI layers. Please do not throw sausage pizza away. Please do not take salespeople's advice. These will help you recall the order of the layers easily. There you have it, hackers, the OSI model demonstrated in a nutshell. I hope this breakdown helps you on your journey to cracking OSCP. If you found this video valuable, don't forget to hit the like button and share it with your fellow ethical hackers. Stay tuned for our next video where we will continue to unravel the mysteries of ethical hacking on our Cracking OSCP, your roadmap to ethical hacking success series. Until then, keep learning, keep hacking, and I will catch you in the next one. This is Kailash Parshad signing off from HackProKP. Happy hacking!